In this video, I'm going to go through the quadratic formula. There are three methods for solving quadratic equations. The first method is by factorizing. The second method is by using the quadratic formula, and we'll go through that now. And the third method is by completing the square. So just to remember how to solve quadratic equations by factorizing, to solve means I'm finding the value of x that makes the equation equal to 0, and really the value for 0 is a y value. So what is the x value that gives us a y value of 0? So we would factorize, we would recognize that a three-term quadratic came from a double bracket. We would look at the signs, they're both pluses, so that means both brackets have a plus. And x squared comes from multiplying x by x, and then we will always list the factors of the constant, the number on its own. Thankfully, 2 only has 2 factors, it's a prime number, so my only options are 1 and 2. And when we check, 1 times 2 is 2. And then I want to make 3x, and this comes from multiplying 1 by x, which is x, and also 2 times x, which is 2x, and when we add them together, we get 3x. So this is factorizing. Once I've factorized correctly, I want to solve. So I've got two unknown numbers. When they multiply together, they give me 0, which means either the first number equals to 0, so either x plus 1 equals 0, or x plus 2, my second unknown number, equals to 0. Solving that equation means that x equals -1, and solving the other equation means that x equals -2. And you get two answers, two values for x. If you use either of them, you'll get a final value of 0. So if you use x is -1 and substituted -1 plus 1, -1 plus 2, this gives you 0. 0 times 1 equals 0. And if you substitute the -2 again into the double brackets, the second number will be 0, and the equation will equal to 0. So solving is about finding the value of x. The quadratic formula is a formula that gives us the two values for x. The first thing you need to know is that quadratic formulas are in the form ax squared plus bx plus c. A stands for the coefficient of x squared. B is the coefficient of x, the number attached to x. And c is the constant term, which means it's a number that doesn't change. It's a number that doesn't change, therefore it is constant, it doesn't have a letter attached to it. Now, the plus here and the plus there are generic. It means the quadratic expression can have a plus or a minus, but we write it with a plus, generically with a plus. This is the quadratic formula. To get x, which is what we're solving the equation to find, you would do -b, so the negative of the number next to x. Plus or minus means one time you're going to type it with a plus, or you're going to calculate it with a plus. The next time you put it in, you're going to use a minus. You don't use the plus and the minus at the same time. But we have the plus and the minus because there are two answers. And that's how you get the two answers. One time you calculate by adding, another time you calculate by subtracting. And then it's the square root of b squared minus 4 times a, which is the number coefficient of x squared, times c, all divided by 2a. It is very good if you are able to learn that formula. You should learn that formula, but it is given in your exam formula sheet. And you will always have two values for x. Now, just a note to say, if after your calculation the number you get inside the square root is negative, then something, if you end up with a negative 25, for example, you've made a mistake and you'll certainly get a calculator error. Let's have a look. You've got various expressions and you need to decide what the values of a, b, minus b, b squared, and c are. A is the number next to x squared, so a is 2. B is the coefficient of x, and it's a positive 3. So if b is a positive 3, negative b means it's negative 3. B squared is 3 squared, which is 9. And c is the constant on its own, which is a positive 5. Please remember that b squared is always positive. Any number squared is always positive. So even if b was a negative number, 3 squared, negative 3 squared means negative 3 times negative 3, which is a positive 9. So b squared is always positive. For the next question, a is the number next to x squared, which is 5. B is the coefficient of x, which is a negative 6. So if b is negative 6, negative b, negative 6 is a positive 6. It's the opposite sign. B squared is 36. It's always positive. And c is a plus 1, a positive 1. Question 3. A is the coefficient of x squared. B is the coefficient of x, which is a negative 1. So that's negative 1, which means that negative b is a positive 1, b squared positive 1, and c is negative 4. So you need to be able to pick out what A, B, and C is, and I would very strongly suggest that when you start solving the quadratic, you lay it out like that so that you don't make any mistakes. For question 4, the coefficient of x squared, well, it's a 1x squared. The coefficient of x, remember b is the coefficient of x, so it's not 3, 3 is the constant. B is the coefficient of x, which is minus 2. So negative b is a positive 2, b squared is 4, and c is the constant term, the number without the letter, which is 3. So again, it doesn't matter where they write the x squared or the x term or the constant term. You have to be very clear. It's not the first thing that's written. It's the coefficient of x squared or the coefficient of x or the constant, regardless of where it's written. A is the coefficient of x squared. So A is 3. B is the coefficient of x, which is negative 2. Therefore, minus b is a positive 2, b squared is 4, and c is 1, positive number. And then for number 6, the coefficient of x squared is a negative 4. B is the coefficient of x, which is a positive 5. So negative b is a negative 5. B squared, always positive, is 25. And c is 1. And then for number 7, the coefficient of x squared, which is a, is 1. The coefficient of x is 2. So b is 2. negative b is -2, b squared is 4, and there isn't a constant term, so that's a 0. And for 8, the coefficient of x squared is 1, so a is 1. There is no x term, so b is 0 minus b is 0, b squared is 0, and c is the constant term, which is -30. So the clue is often in the question. Quadratic formula is great when you can't factorize. Factorizing is often the easiest, quickest thing, but not every expression factorizes. And often the hint to kind of knowing whether it factorizes or not quickly is if you see this. Solve this equation, give your answer to 3 significant figures, generally means that it's best to use the quadratic formula. Your first step is to extract the values that you need. So a is 3, b is a +5, so minus b is a -5, b squared is a +25, always positive, and c is -4. And I'll remind you what the formula looks like. The x, to get x, it's minus b plus or minus b squared minus 4ac inside the square root, all divided by 2a. So let's start putting it in, and you get 2 marks for writing this out. This is usually a 3-mark question. So we start with -b. That's why I got you to find what -b is. -b is -5. Plus or minus square root b squared. So b squared is 25. Minus, I like to put it in bracket, but rules of BidMaths means that we're going to do the multiplication first anyway, but I just like to put 4 times a times c in brackets. So multiplied by 4 times a, which is the 3, and then times c, which is -4, so times -4, and then all over, and again I like to put it in bracket, 2 times a, which is 2 times 3. And let's color code that one too, the 25, the b squared. So here's the calculator, and I'm going to start by using the plus. So I'm going to start by typing it in with a plus to get my first answer. So I type the fraction first, and I start with the numerator, -5 plus square root 25 minus brackets 4 times 3 times -4, close brackets. If you open brackets, you have to close the brackets. I go to the bottom, I open my brackets, 2 times 3, close my brackets, equal. And then because I wanted the 3 significant figures, I press the SD button, and I have 0.591 because the 6 rounds the 0 up. So 0.591 is the first value for x. X equals 0.591. And then I'm going to do the same thing, but instead of that plus, I'm going to type it with a minus. If you use your arrows, you should be able, so I'm clicking on that left arrow to go back, and I'm going to delete the plus, put a minus, and then put an equal sign quite easily, and then SD button, and this gives me x equals -2.26. Remember, I start counting the significant figures from 2, The other answer, the first digit was the 0. So that doesn't count as a significant figure. So 2.26 because the 7 rounds the 5 up. So x equals negative 2.26. And these are the two answers for x, the three significant figures. Again, solve this equation, give your answer to three significant figures. Remember that to solve a quadratic equation, it has to equal to 0. So the first thing you're going to do is rearrange to get the equation to equal to 0. So I'm going to take away x squared from here. They cancel. And I'm going to take the x squared from the 4 squared because they are like terms. So I now get 3x squared. I also have to take away the positive 2x. And I take it away from here. There are no like terms, so it will simply appear as negative 2x. And then I have the constant term minus 3 equals 0. So that's my first step. I've rearranged and the equation now equals to 0. I then start identifying where a, b, etc. is. So a is the coefficient of x squared. B is negative 2, the coefficient of x. Minus b is therefore a positive 2. B squared is a 4 and it's always positive. And c is negative 3. And x equals minus b, that's my starting point, and minus b happens to be a positive 2, plus or minus square root, b squared is 4, minus 4 times a times c, all over 2 times a, which is 2 times 3. Again, you'd get your calculator, and you'd get your fraction button, 2 plus square root 4 minus open brackets 4 times 3 times negative 3 divided by 2 times 3 and equal, and SD button 1.39 to 3 significant figures. So x equals 1.39 to 3 significant figures. That's the first answer. And if you use your click on the left arrow, you can edit the plus, delete, put a minus, press equals, you get your second answer. It's minus 0.721. So minus 0.721 because the 7 rounds the 0 up. Now, you can, of course, be given worded or shape questions. And remember, this is all about solving quadratic expressions. And if you had a shape that had x terms as part of its measurements, you cannot get a quadratic expression. So a quadratic is an expression that has an x squared. You cannot get a quadratic expression from simply finding the perimeter. So the perimeter is all the sides added up. So remember, these two sides that I've highlighted in green are the same, and the orange ones are the same. So the perimeter would be 3x plus 3x plus x plus x. We're not multiplying, so there's no powers. I'm simply collecting like terms. So that's 6x, add 1 is 7, add 1 is 8x. No quadratics. The same with the second rectangle. I've got an x plus an x, and then I've got a 10 minus x, add a 10 minus x. And if I add them up, well, x take away x is 0, x take away x is 0. So actually this perimeter is 20. The only way to get a quadratic is by finding the area of the rectangle. 3x times x is 3x squared. And x times 10 minus x is written as such, the x at the front and then 10 minus x inside the bracket, and you multiply them out, 10 times x and x times x, 10x minus x squared. So you can see that when you find the area of a shape, that's where you get a quadratic expression. Now, it's not, we'll have a look at this question. Sometimes it's very straightforward. A rectangular flower bed measures 2x plus 5 meters by x by plus 3 meters. So these, even if they're not written in brackets, you should put brackets around them. And this particular rectangular flower bed has an area of 45 squared meters. So they've set it out quite nicely. Here's a rectangle. Define the area of the rectangle, its length times width, and we know that one of them is 2x plus 5 and the other one is x plus 3 meters, and the area is 45. Well, area is length times width, so length times width. Remember, two brackets next to each other is a multiplication, so here's my length times width equals area, so it equals 45. We've already set up the equation. Now look at the wording of the question. It says show that x must satisfy the equation that. They've basically given you what your final line of the answer should look like. You've got the area. You know that you're going to do length times width, so you're going to multiply out the bracket. So I've got my grid, 2x plus 5, x plus 3. So this is 2x squared plus 5x plus 6x plus 15. Remember that you're going to add and collect like terms. So 6x add 5x is 11x. So this double bracket gives us 2x squared plus 11x plus 15, and it equals 45. But of course, I want it to equal to 0. So I have to take away 45 from this side, take away from 45 from the 15. So this goes to 0, and my final equation is 2x squared plus 11x minus 30 equals 0. And we can use the quadratic formula to find the values of x, or you can have a think and see if it factorizes and do that. But since we're using the quadratic formula, that's what I'm going to do in this video. So I've got a is 2, b is a positive 11, so minus b is a negative 11, b squared is 121, it's 11 squared, and c is negative 30. So x is, I start with negative b, which is negative 11, plus or minus square root 121 minus 4 times 2 times negative 30, all divided by 2a, which is 2 times 2. Again, you put it into a calculator, minus 11 plus square root 121 minus 4 times 2 times negative 30 and times 2 times 2, or divided by 2 times 2. So the first answer is x equals 2. And the second value of x, if I use my left arrow, delete, put a minus in, is minus 7.5. Now, for these questions, it's really important to understand that even though there are two values for x, one of them might not be a possibility, because they haven't just asked you to solve this equation. You've solved, so you've done this part. You found the values of x. But you're asked to determine the dimensions of the flower bed. Well, one of the dimensions, to get it, it's 2x plus 5. So imagine if we take x to be negative 7.5. 2 times negative 7.5 is negative 15. Plus 5 means that this flower bed measures minus 10 meters. Well, it's a real dimension. You can't have a minus 10 meters. So this value for x is rejected. It doesn't work in the real context of this question. And I have seen mark schemes where they give you a mark for rejecting a particular value for x. So the value for x that we're going to work with is x equals 2. So the first dimension is 2x plus 5. Well, that's 2 times x, which is 2 plus 5, so that's 9 meters. And the other dimension was x plus 3. So that's 2 plus 3, which is 5 meters. So that flower bed measures 9 meters by 5 meters. So that was a shape question. A worded question says the following: 2 consecutive positive numbers are picked. Consecutive means one number after the other. 2 consecutive positive numbers are picked. The first number is called x. Write an expression for the second number. The second number is not 2x, because that means x multiplied by 2. So if I say, if the first number is 1, or let's say, because we don't know what it is, let's say it's 3. The next number up is 4. It's not 6. It's not 3 times 2, which is 6. The next number is 4, and they are connected by an add 1. So consecutive numbers are connected by an add 1. So second number is x plus 1. So that's my second number. Write an expression for the product of the two numbers. Well, product means to multiply. So I'm going to multiply the first number, which is x, by the second number. And when we have a multiplication, we write brackets. We write them next to each other. X times x plus 1. The product of the two numbers is 42. So x times x plus 1 equals 42. That's an equation. So the first thing you would do is to multiply out the brackets. X times x is x squared, x times 1 is a positive x, and that equals 42. But you know that you cannot solve a quadratic equation unless it equals to 0, so I'm going to take away the 42, and I now have x squared plus x minus 42 equals to 0. And again, you can use the quadratic formula, although I do think this one is rather easy to factorize. So if you think of the factors of 42, this is a negative 42. So one of them is going to be a positive, one of them is going to be a negative, and this is an x squared without, well, coefficient is 1. So again, easy, x times x. One of them is positive, one of them is negative, and I want it to give me a positive 1. Factors of 42, sorry, not 62, 42 with a difference of 1. 6 times 7 is 42, and the difference between them is 1. So I'm going to put a positive 7 and a minus 6, and that will give me 7 minus 6, which is 1. So either x plus 7 equals 0 or x minus 6 equals 0. So x equals minus 7 or x equals to 6. Remember, I'm solving the equations. So minus 7 plus 6 to give me the values of x. So here are my two numbers. If the first number x is minus 7, the next number is x plus 1, which is minus 6. So here are the two possible numbers. If the first number is 6, the next number up is 7. So that's the combination of the two numbers that have a product. They multiply to give us 42. Now, I wanted to go through how to write even and odd numbers in this video, and you'll meet it again and you'll need it again. So the definition of an even number is that it is divisible by 2, or it's a multiple of 2. So simply writing x could be any number. If you're solving an equation and you're solving for x could be any number, but it's not necessarily an even number. To make sure that it's an even number, you would say 2x, because that would make it a multiple of 2, and therefore it is definitely an even number. Now, if I want to go to the next even number, if I have 4, 6, 8, all of these are connected by adding 2. So the next even number up is 2x plus 2. If you want to go to the even number before 2x, well, again, it was 2 less. So 2x minus 2 is also an even number. So when you're thinking about representing odd and even numbers algebraically, this is how you do it. Now, odd numbers, well, let's have a look. This is an even number. That's an odd number, and that's an odd number. And you can see that from the even number, you would add 1 to get an odd, or you'd subtract 1 to get an odd. So again, I would put the first odd number as 2x plus 1. Of course, something like 2x plus 3 is also odd. 2x minus 1 is also an algebraic representation of an odd number. So just keep that in mind for any questions that particularly reference even and odd numbers. And now we're going to get to the final stages of the kind of exam questions that are often asked. This rectangle has a width x centimeter and a perimeter of 30 centimeter and an area of 56 centimeters squared. Show that x squared minus 15x plus 56 equals 0. It means this information, use it to create an equation, and once you expand the brackets and do everything you have to do, you're going to end up with something that looks like this. Now, let's have a look at the information that they've given. This rectangle, so I've got a rectangle. Its width is x centimeters. So that's the width. You're told something about the perimeter, but you know that perimeter does not give an x squared. You're also told something about the area, and you know that ultimately you're going to have to use the area to get this. But the area of the rectangle is length. So let's put length times width equals area. I've got width, it's x, but I haven't got the length. You have to work out the length first. Your step 1 is work out the length of the rectangle in terms of x. It has to have an x, no other letter, because that's the only letter in the quadratic equation you've got. So work out the length of the rectangle in terms of x. Well, how do I do that? You're going to do that by using the perimeter, by creating an equation for the perimeter and rearranging it to get to make the length the subject, to make the length the subject. So this is length and this is length. I'm going to call it L because length is what we're trying to find. So what is the perimeter of this rectangle? Well, it's an x plus an x plus a length plus a length, and it equals 30 because that's what the question tells you. The perimeter is 30. So this is 2x plus 2L, 2 lengths, equals 30. Let's rearrange this. I'm going to take away the 2x from both sides because I want to make the length the subject. So this is 2L equals 30 minus 2x, but I don't want 2 lengths, I want 1 length. So I'm dividing by 2, which means I'm dividing everything by 2. So here I have 1 length is actually 15 minus x. And I've got my length in terms of x. So I've used the perimeter to find an expression for the length in terms of x. My step 2 is to actually create an equation for the area of the rectangle, because that's how you get your quadratic. So create an equation for the area of the rectangle. So the area of the rectangle is width, which is x, times length, which is 15 minus x, and that gives us 56, because that's the area. And then I start multiplying out the brackets. So 15x minus x squared equals 56. Now be very careful, because the temptation is to take away 56 from both sides to make it equal to 0. But if you have a look, this says a positive x squared, and what you've got here is a negative x squared. So we're actually not going to move the 56 that way by subtraction. We're going to move the negative x squared that way by addition, and then we're going to move the 15x also on the other side by subtraction. We want the x squared to be positive. So I'm going to add x squared from here, so it will go. I will take away 15x from here, so it will go. And I will do the minus 15x and the plus x squared on this side. So now I have 0 equals x squared, which is my positive, minus 15x plus 56. And yes, it's on this side, but it's exactly exactly the same thing, a positive x squared, a minus 15x, and a positive 56. So I have shown the equation. And then it says, solve this equation to find the possible values of x. And again, I would always look and think, can this be factorized? What about the factors of 56? This is a plus 56, and this is a minus x term. So this is coming from a double bracket where both of them are minuses, because a negative times a negative is going to give us the positive 56. And you can check minus 7 times minus 8, positive 56. And then if you minus 7 minus 8 is minus 15. So x is negative 7, x minus 7, and x minus 8. So either x minus 7 equals 0 or x minus 8 equals 0. That means x is 7 and x is 8 because we're solving the equations. You could have used the quadratic formula as well, so it's not a problem how you find your values for x. And this one doesn't ask us to find the dimensions of the rectangle. So, and in any case, both of the answers are positive, but it doesn't ask us to find the dimensions. It says solve. So even if we had got a negative and a positive value, we'd keep them both. Solve, didn't mention the dimensions. I keep both answers regardless. But very important when you're reading the question to possibly do a little sketch. Notice that the only way to get a quadratic is by using the area, but you can't use the area until you have both dimensions, and you will often need to use the perimeter to get one of them. That's quite a classic exam question here. Part C says find the possible measurements for the rectangle. So one of them is x and the other one is 15 minus x. So one of them is x and one of them is 15 minus x. So when x is 7, the other one is 8, and when x is 8, the other one is going to be 7. So 7 and 8 are the combination we have. So they don't just have to give you rectangles, they can give you trapeziums, triangles, complex shapes. So this is an L shape. And my first question was find the length of the blue lines, but in fact I might make one of them pink and one of them blue. So the pink is the horizontal line, and it continues the x, and altogether it's a 10. So that pink line is a 10 take away x. That's the length. And the blue line is a vertical line. Altogether it would make 10, but we've got that little part which is 2x. So this blue line is 10 minus 2x. And then they could potentially say the area of this shape is, and give you a value for it. So I just wanted to explore how you would find the area of this shape. For a complex shape, you would split it up into 2 rectangles. Let's call this A, let's call this B. Of course, you could have split it up the other way as well. Doesn't matter how you split it up. So for A, my width is x and my length is 10. So area A is 10 times x, which is 10x. Area B is actually 10 minus x times 2x. Always put the one term at the start and then the bracket after that. And when you expand, you get 2x times 10 and 2x times negative x. So you will get 20x minus 2x squared. But you want the total area of the complex shape. So it's those two added together, the two areas added together. So 10x add 20x minus 2x squared. 10x add 20x minus 2x squared. When you're adding, you are collecting like terms. Powers don't change. So these are the like terms, and the total area is going to be 30x minus 2x squared. So the area of that shape is 30x minus 2x squared. And if they give you a value for the area, you now have an equation that you can solve. Okay. The final question relates to a right-angled triangle. So this is a right-angled triangle. Show that x squared minus 6x minus 15 equals 0. We've already discussed that the perimeter, adding them all up, is not going to give you a quadratic. We know that the area gives a quadratic, but they haven't given you a value for the area. They haven't said the area of this triangle equals, and therefore you can't use area. And since we can't use area, we have to find a different way to get a quadratic from a right-angled triangle. And that way is by using Pythagoras Theorem, because the Pythagoras Theorem formula is all squaring the sides. So Pythagoras says a squared plus b squared equals the hypotenuse squared. And you don't need the square root, because the square root is only used at the end when there are numerical values. But this is the formula for Pythagoras, and this is what you used without the square root, because you don't have any numerical values, it's all algebraic. So A is one of the shorter sides, and B is one of the shorter sides, and the hypotenuse is the side opposite the right angle. So A squared, and again, it doesn't matter which one you call A and B. I mean, I could have called this A, I could have called this B, doesn't matter. A squared, well, A is x, so it's just x squared, plus b squared, it's x plus 1, so this goes into a bracket, x plus 1 squared. It's not x squared plus 1 squared, it's the whole thing squared, like this. And then equals h squared, which is x plus 4 squared. Now remember, these squared brackets mean a double bracket. So x plus 4 squared means x plus 4 times x plus 4. So I've got x squared plus x plus 1 times x plus 1 equals x plus 4 times x plus 4. And what do you do when you have brackets? You multiply them out. So I've got x squared plus, I'm not going to use the grid, I'm just going to do it quickly. I've got x squared plus x plus x plus 1. So that's the double bracket. I've multiplied it out. And then equals x squared plus 4x plus 4x plus 16. You can use the grid method, multiply out the bracket, collect like terms as well. Now I'm going to start collecting like terms. X squared plus x squared gives me 2x squared. And then I've got x plus x gives me a positive 2x and then plus 1. And on this side, I've got x squared, and then I've got 4x plus 4x is 8x plus 16. But of course, it doesn't yet look like this equation, which we want to show. Remember, it's almost always that the x squared is positive. So when we start subtracting, we need to make sure that the x squared remain positive. So we need to subtract x squared from here and from there. And then we subtract the 8x from here and the 8x from there. And we subtract the 16 from here and from there. All of that gives us our 0. 2x squared minus 1x squared is 1x squared. 2 take away 8 is minus 6x. 1 take away 16 is minus 15 equals 0. And when I check, that's exactly the equation that they gave you. And again, part B could be to find the solutions, and part C could be to find the dimensions. And if one of the x's was a negative answer, you would have to reject it and say that x can't be negative because the length, the measurement, the dimension of a triangle cannot, or a shape cannot be negative. So this is all quadratic equation, the quadratic formula.